Let's look at example 1 now. So using x values, x from -4 to 0. Draw the graph of y is equals to x minus 5. And of course, the solution. The first thing that we have to do is to come up with the table of values for at least 3. In our case, we're going to select just 3 values of x that are between -4 and 0. And these values are -4, -2, and 0. Then we are going to calculate the associated y values. That is to say, when x is 0, y of 0 is going to be given by, so wherever we had x, we substitute that with a 0, so that we have 0 minus 5, which is equal to -5. We do the same thing for -2, so y of -2, wherever we had x, we now substitute with the -2, so that we have a -2 minus 5, which gives us a -7. We move on to the last value, -4. So y of -4, that would give us a -4 minus 5, which is a -9. Now that we have the x values with the associated y values, we are going to think about the scale to use. So according to the graph paper that we have on the right hand side, if we use 2 centimeters, so 2 centimeters is that one box, which is the bigger box. That is 2 centimeters by 2 centimeters is highlighted here. So if that one box would represent 2 units, that could fit on the y-axis. On the x-axis, it would still fit with the x values that we have, but why squeeze our work when we can actually make it 1 unit for the x? So for the x, if we go from -4 up until 0, we can actually fit the scale there. So 2 centimeters will represent 1 unit on the x-axis. However, on the y-axis, we might have a challenge a bit. So let's use 2 centimeters to represent 2 units, because for the y, the scale is a little bit wider. Now, we are going to express our values in terms of a table. That would be easier to read. So when x is -4, we got our y to be -9. When x was -2, our y was a -7. Our x is 0. Our y was a -5. Great. So now let's plot the axis, the x-axis, and the y-axis. So that is how we would plot it. So using 1 unit from 2 centimeters on the x-axis and 2 centimeters representing 2 units on the y-axis, we are going to have that. But we could still use the same 2 centimeters to represent 1 unit in the y-axis as well. But for the sake of explaining the uniformity, I think that's still okay. That's still fine. So whatever you use as your x-axis scale, maintain that scale on the x-axis. The y can have a different scale, but maintain whatever scale you have. Right, so the next thing would be to plot the points individually. So we'll start with the first point. The first point is -4 minus 9. That is where it is located. So -4 on the x, -9 on the y. We move on to the next point, which is -2 minus 7. So -2 on the x, -7 on the y. We go on to the last point, 0 on the x, -5 on the y. Great, so we have our 3 points. Then the next thing would be to use a straight ruler. And on graphs, we use pencils. So we connect all the 3 points, place our ruler on all the 3 points, then draw with a pencil on top of these 3 points, so that we have a line coming out like that. So that would be our y is equals to x minus 5 graph. Now, why were we saying that you need at least 3 points? Let us look at this scenario. Now, supposedly, we have made one mistake. Say on the x is equal to minus 2, the y of minus 2 would give us, say, a minus 3, say, because you know it happens, especially when you are under examination setup, where you are under pressure. We all make mistakes. So for you to realize whether you've made a mistake or not, you might need the 3 points. With only 2 points, it might be difficult for you to see. Let's take a look at this scenario. So we have one of the points being wrong. So in this case, we know which point is wrong, and I've highlighted it with a yellow. So when you now come to plot your line using your ruler, you would see that you've got 3 points, but the 3 points are not connecting to a straight line. That automatically means that there is a mistake somehow, because it could either be this line that we have right now, that is the correct one, or it could be that we have the purple line, which is the correct one, or even the last line, which is the red one or orange one, depending on how you see it. So that indicates a problem. So it means that you have to go back to your drawing board. You have to identify the one that could have been a wrong value. Chances are high it's just one value, or even 2, or even 3 values that you've calculated, because there could be an error in the way in which you were calculating the values, and that would help you identify the mistakes beforehand. Now let's take a look at a scenario where one decides to just stick to 2 values instead of a minimum of 3 values in the x values. So we have one person who had 2 values, and under pressure, they made a mistake. So they calculated the y of minus 2 value wrong. So that would be what they would plot. They wouldn't even detect that they have made a mistake. So unlike the at least 3 points, it's easy to see where you have made a mistake and detect where the mistake is coming from. But if you just have 2 points, then you are likely to make mistakes and go away without realizing that you have made a mistake. In your thinking, you might assume that you've answered the question well, when you might have made a huge mistake. So take note, we need at least 3 values.